example 3, we're going to find a quotient with a remainder. So when we divide this, we're getting a remainder. So, think back to 5th grade or 6th grade. So when I divide this, I say what times 4 gets me close to 5, and that'd be 1, right? Bring down 2 zeros, and then we subtract. Right, then we keep going. What we get 1, 1, 2. And then when I say what times 4 gets me close to 11, right, that's 2, so that's 8. Bring down the 0, then we subtract, right, and then eventually, we have a remainder, 32, and then here, say it gets 8, it's 32, and then we can subtract, right, and then we have a remainder of 0. If we had a remainder of, say, 1, we would put like an R or something like that, right? Well, here when we run through the same thing, we're going to have a remainder at the end. Okay, but how we write that remainder is we write that remainder as plus whatever's left, our remainder, over what we divided by z minus 5. So that's how we do writing the remainder. Okay, so same thing as kind of the last example, example 2. What times z is a z, or 3z cubed? That would be, I need a 3, and then I already have a z to the first, so I need a z squared to get to a 3z cubed, and then I also times that by -5. That'll give me a -15z squared. I put it under here because that's a z squared as well. And now I just subtract, so that's subtracting, and then I subtract this one, which is addition, because this I want to go away, right? Just like I got this 5, not quite to go away, but that's the idea. Okay, and then bring this, and I get 1z squared left. Maybe put a z like that, and then I say, okay, what times z is a z squared? That would be just a z, a positive z, right? So I distribute that to both. I get a z squared, and then I multiply it by the -5, and I get a -5 z. I probably should have brought these down. Negative z, and put it underneath here. 7z and a positive 3. Okay, so then I can put a 0 there. Subtract these, so that's subtract, that becomes addition. Subtract 0 is not going to do anything. That goes away. I get a -2z and then a positive 3, right? And then I got to ask myself, what times z is a -2z, right? So that'd just be a -2. So I get a -2z, and then I got to also multiply that by -5, and I get a positive 10. Now I got to subtract that. And so that becomes positive, that becomes negative. So then I get 0 here, and I get -7. Now I can ask myself, what times z is a 7, a constant? I can't do that, right, unless I have a negative exponent. So that means I got to stop. Anytime you get to your constant, so notice that this is divided by 1, by a 3 there. So when I divide by the same base, like we did in example 1, we subtract exponents, so that should be a 2 exponent, and that's what I start with, right? So 2 exponent, 1 exponent, a constant exponent, right? So there I should stop, because now I have my remainder. So anytime you get down to your constant, the next one that you get is your remainder. So -7 is my remainder, and this is how I write it. So I have 3z squared plus z minus 2. Now I have my remainder, -7. So I can put negative, and then 7 over what I divided by z minus 5. And that's how I write my answer. So that, if I took that and I times it by this, I would get this polynomial. Right? Okay, so that's it for that example.